Hi, this is our monthly Longhorn community meeting, and I'm Shane Yang from Rancher Labs. With me is Jason Van Blarco, our Director of Community in Rancher Labs.
Awesome. Let's get started.
Yeah. Today we are going to demonstrate the latest release of Longhorn, which is 0.6.2, and also we are going to share our plans for the future releases. And you can see that how our release process, how our development process work in the process as well. So let's get started. I'm going to share my screen. All right. So Jason, can you see my screen?
I can see it just fine. I see Rancher 228 running.
Yeah, Rancher 228. So the font size is right.
Yes, this is very readable.
Okay. So for the Longhorn 0.6.0 release, we did a big upgrade. We did big re-architecture on the how Longhorn spin up engine and the processor and the replica processes. So before, every engine and the replica process, as you may see, is using one pod of Kubernetes, and now we consolidate them into one pod per node. In fact, two pods per node to save the resource of Kubernetes pods, because Kubernetes has a limitation of 110 pods per node. So to demonstrate that, I'm going to start up the Longhorn 0.5.0. And of course, you can just click launch and everything should be up in a minute. So this is Rancher, and we're using Rancher to launch Longhorn, which is essentially a Helm chart. And you can click the workload to see how things are going for this namespace and for this project. And when in the app, you can see that this specific app. Now we can see that the Longhorn 0.5.0 release has been deployed, but still in the process. And we just need to wait a minute. Let me see how so I think we're waiting for the engine image to get installed. All right, I think everything seems up. So now after you click this /index HTML link, you are going to get the Longhorn UI. You're probably already familiar with this. And we don't have any volume to show right now, so I'm going to start in a workload to use Longhorn. So this is a standard WordPress, and I'm going to use WordPress to demonstrate a few of Longhorn's features. And we want to enable the persistent volume and use Longhorn as a persistent volume provider. And also, the WordPress has two parts. One is WordPress, another is MariaDB. And we want to use Longhorn for MariaDB as well. So let's click launch. So as you can see that the Longhorn has picked up the changes from Kubernetes. Kubernetes talked to Longhorn and asked Longhorn to create these two volumes. And you can see we know that volume has been one volume has been used by the WordPress, another one is used by MariaDB in the WordPress. You can see the workload information in the Longhorn UI. We pick up that from the Kubernetes. And the WordPress is in the starting process, and you can see that MariaDB is initializing the database. Will take, I think, a few seconds to do that. I think MariaDB is almost fine. So for the time being, let's take a look at the Longhorn UI. You're probably already familiar with this, but if you click into the volume details, you will see that what the volume looks like, what's the general information, and what's the endpoint, which means that what are the block devices we expose on that node for this workload. and what's the size, what's the actual size, which is the space Longhorn has been used on your real hard drive. And the same thing is continuous written data in them. And the right side, you can see that the replica list, which by default will have 3 replicas, and you can see where the replica was located at, the data, where the data stored, and what's the node name of this replica. And down here, we have snapshot. You can simply take a snapshot. And of course, later you can revert to it or create a backup using it. Another one we have is a recurring snapshot backup. So you can backup your data once per day, like 3 a.m., or you can do per hour. We'll demonstrate that later. So now the WordPress is up, and everything looks good. And let's log in and just write some random post in there. Yes. So the post has been posted up. And so let's take a look at how Longhorn works in the 5.0 release, 0.5. So as you see that I'm going back to the storage project and the Longhorn system namespace inside it. And you can see that, so we have 2 volumes, and each volume has been brought up 4 parts. And you can see that the part name is like it's a volume name is PVCC0F something. Let's see which one is this. C0F is MariaDB, yeah. Sorry. So we have some volume name -E, which means this one is running as an engine, and the volume name -R. That's 3 different of them. Those one are running as the 3 replicas of this volume. So another one, you see that for another volume also spin up 4 parts for that. Sorry. So, sorry. So let me demonstrate how do we upgrade to the latest release and see how things changed. To upgrade, you only need to just click this upgrade available button. Don't need to change anything and click upgrade. During the process upgrade, this the volume is still connected, and Kubernetes is starting to upgrade the manager into the 0.62 release. So there are 2 parts in the Longhorn. One is the Longhorn engine, which implements the data plan and the volume itself, and the Longhorn manager is used to orchestrate the Longhorn engines across the different nodes in the Kubernetes. Let's see that we're waiting for the driver to be installed. Sorry, I think I got a little bit cold.
It's that time of year.
Let's see if I'm waiting for the engine image to be up. Yes.
It's getting there.
Yeah. So now you see that there's the multiple instance manager -E or instance manager -R running. And this is the new for the 0.62 release, which we have we have a re-architecture going. And in the future, all the engine and the replica process will be running on the same in the same part as in the instance manager. And the instance manager -E means that this instance manager is for the engine, another one is called for the replica. You can call them engine manager or replica manager instead. So I think it's almost there. Let's take a look at the UI. So as you see, the version has been upgraded to the 0.62 release, and you can click the volume. You can see that something shows up that, okay, this green arrow before the healthy state. That means this volume are still running, but we need to upgrade them in order to complete the Longhorn upgrade process. So you can also see here from the engine, now we have two versions of engine image available. One is called, of course, the Longhorn engine 6.2, which is in the ready state. Another one is engine 5.0, and you can see the status is incompatible, so you cannot live upgrade from this version. So what we are going to do now is we shut down the workload, and this one will result a temporary down of the workload, and we shut down workload, and then we upgrade the engine and bring the workload back. So just confirm that even we are on the new version, and the Longhorn Manager's upgrade doesn't really impact the data plan. So you can shut down the workload, and doing the workload upgrade, the image upgrade at the time which is convenient for you. So normally what we do to upgrade, to shut down workload is like, say, just scale the WordPress and the MariaDB back to 0, which then resulting the workload to be released, and the volume will be released and detached. And you can see that happens. Okay, so now WordPress volume has been released. Let's go back to the MariaDB and scale back to 0 as well. So we're waiting for MariaDB to be shut down as well. Okay, as you can see here, MariaDB's 4 pods are still running. They haven't been shut down yet. Okay, now it's gone. So now we can click upgrade engine, and we want to upgrade into the latest version, and click OK. And now you see the green arrow disappeared, and that means that engine upgrade has been successful. And now you can start your workload, and we are starting from the MariaDB. And now you can see the MariaDB volume has been attached and becoming healthy. In fact, you may notice that this takes this much faster than what we had before in the 0.5 release, because the starting process is much faster than starting the pod. Pod is starting still very fast, but the Kubernetes need to do a lot of work to orchestrate pod and to scheduling them. And the things we already know, that there's many information we already know, so we don't need to Kubernetes do that. So we save some time here. And then I'll go back, I just bring the WordPress up. Yeah, I think it'll take about 2-3 seconds. So let's see, MariaDB. Oh, MariaDB is running good. The WordPress, still waiting for, yeah. All right, looks good now.
Getting there.
Yeah. It's late. All right, so this is the same workload we had before the upgrade. Now we bring it back after we upgrade to the new version. And now you can see, in fact, no matter how many, let's take a look at storage and workload. No matter how many volumes you have, you're only going to have one engine instance manager per node, which is handling the attaching to your the workload, to attaching the volume to the node that workload is running on. And you're going to have instance manager, a replica instance manager for every node if they have available disk, which means that, say, in the node, you can see that for every node, we have a default config disk. If there's no disk on this node, there will be no replica manager because we're not going to schedule any replica on that node, so it will be waste if we run your replica manager there. And there's no, so now you can spin up as many volumes you can, of course, subject to your system resource, but without worrying about that hitting the limitation of the Kubernetes node. There's a few other features I want to show you about is something like, for example, now when you have create a backup, in fact, I probably haven't set the backup yet. Yes. A moment. Yeah, it looks fine. Okay. So in this release, we add a new feature like if you want to create backup, and I can say that app equals MySQL, and you can add labels to the backup. So later you can identify which backups you are doing, which backup who is who. And now you can see that click into here, and you can see the label. You can see that this user specified label is the app MySQL. And also, we automatically store the Kubernetes status we detected into this label as well. And in case later, if you want to restore from this workload and you didn't add any labels, we can pick up the PVC name and the PV name and try to make a match for your previous setup. And also, you can set labels in the recurring backup as well. So for example, I say that app MySQL, in fact, it's not really MySQL, it's MariaDB. I can return 3, save. All right, and now the backup was being scheduled with the labels, and later you will see that the label were going to be used. Another thing is we added the progress. Yeah, in fact, I just created backup now. It should be easier to see. We had the progress report for the backup and the restore in this version. Okay, I think this backup is way too fast because you can see that the progress is 100% just instantly because we haven't written any data to it. Yeah, but let me try the restore, and that one should be a little bit slower. And I just randomly restore this one, and you can see this backup. Yeah, that's the one we created by our recording job. So recurring job label was set, and MariaDB label is what we had when we started creating recurring job. I can just restore it to like demo restore. And in this release, whenever you restore a volume from the backup, the volume will be automatically attached and without a front end. And that's because that we're trying to just complete the restore before this volume can be used. So now we can, it's still too fast because it's the S3 is running, I'm running manual locally. So, okay. But you can see that there's a progress showing that how long restore has been into and all this kind of information, and can help you to understand that, okay, so if this thing stuck or not. So the backup, you are going to have, that the same thing as the backup. So let me see, what else I want to show? Oh, in fact, we have, let me see, we have added a new mode called maintenance mode. And when you attach to the host, that's basically just saying that oh, I want to look into, I want to do some maintenance for this volume. For example, say I want to make a, if I have take a few snapshots, I want to revert back to it. That's with what you need to do without exposing the block device. Otherwise, you're going to corrupt your data. So that's why we create this maintenance mode for you to easily just revert to a snapshot or troubleshooting and see that what is going on without really concerning about someone externally use the device on the host. We have all other features we have added, like they in the new version, you can specify what's your default data passes. And also you can have, say, you can only select to create default disk on the selective node. This is many users request this because that, okay, they're adding new machines into the cluster, but they don't want to have all the machines automatically create the default disk and start using storage on it. They only want certain nodes with a label, which have that Longhorn to automatically create the default disk for that. So if you enable this option, you are going to need to tag this node Longhorn create default disk to label to node Kubernetes node, and Longhorn will pick it up and only create default disk on those node on this path. Another feature we have to add is Kubernetes temporation. So in the case that if some users want to have Longhorn only the storage only on a certain part of node, and they don't want any other workload like into this storage specific servers, they can set this, and they can set this tank to the Longhorn's node and allow Longhorn to use those nodes, but other workload won't able to use this node. And also this one caveat using this option is because whenever you change the temporation in Kubernetes, they're going to restart the whole deployment or daemon set or whatever part they had. So in order to use this option, you have to have no volume attached. Otherwise, that it will disrupt your current data flow. And also, this another option we added is the soft anti-affinity. And in fact, what feature we add is hard anti-affinity. And in the past, Longhorn is using soft anti-affinity by default. It's like say that, okay, so I have 3 nodes, 1 node is down, and now I have 2 nodes, but I'm trying to start rebuilding. And okay, Longhorn said I cannot find any other node, so let's just compromise and put this fourth replica in the same node of one of the first 2. So many users doesn't really like that. They say those, okay, I can tolerate a temporary node down, and I can tolerate a temporary, say, the robustness compromise, because I don't want to have this effort and this CPU and space and disk space to rebuild a replica so quick. I can just tolerate for a while, and I can bring the node back, and you can still use that node for your third or fourth replica. So that's when, if you disable this soft anti-affinity option, Longhorn will not create any replica or try to schedule replica in the node that already has a replica in it. So that's helps people in some way. And also there's one issue in the GitHub. You can search for replica anti-affinity and should be able to find it. Okay, so I think that's all for my talk on the demonstrate our latest release and some highlight features of that. Okay, I guess. Okay, next I want to show show users that how the Longhorn's development process works. So you can see that, in fact, every our workflow is completely driven by the GitHub. And if you take a look at the milestone, this is our releases. So the next release we're going to happen is we're supposed to be tentatively on November 7th, the release. And the function features we want to add in this one of the precise, yeah. This volume resize is one of the oldest issues we had. We finally got some time and think, okay, with another aspect of the system, we think is good enough, and we are going to tackle this in this next release. So another change is like we want to move our test cases to the Python 3. If you want to write the test cases, those are the integration tests that's running every day for Longhorn, and we aim to maintain 100% pass rate. And another big change maybe coming is that we're going to use the status sub-resources for the Longhorn CRDs. That may require some effort on the next upgrade as well. So if you have any questions regarding how the workflow works, just let me know. Okay. Yes. So any questions?
How might somebody become a contributor to this project?
Yeah, so there's many ways to contribute, of course, and you can, if you, of course, you can raise issues, and also if you spot something, you can directly just raise a pull request. And if you want to do more on the developer side, we have this architecture overview, and this getting started with Longhorn development, and this is supposed to have all the information you needed. And for the simplest setup, you can just install K3s on a Linux box and start using them to develop Longhorn. And the architecture overview is give you a basic idea that how Longhorn's components works and they interact with each other. And also, of course, you can join on this meeting and ask me more specific questions and raise issues and asking for more information and help. So we're pretty glad to do that.
Awesome. Well, that's the only question I had. If you have anything else you want to share, great. And if not, we can go ahead and end the meeting, and I'll get this up on YouTube.
Yeah, so I think that concludes today's meeting, and thank you for attending.
Awesome.
All right.
Well, thank you, Shed, and we'll talk between now and next month. If anybody's watching this, you want to add things to the agenda that you'd like to talk about, go ahead and click on the link in the GitHub link and suggest changes. We'll add them to the agenda, and we'll see you all next month.
See you next month.
All right. Bye now.